Hello to my wonderful basic and intermediate algebra class. Today we're going to talk about, or this video is going to talk about lesson 3.3, which is about coin and mixture problems. They can be kind of confusing, but hopefully I can give you some pointers to make it all make sense. I do also want to say that the book does a really good job of showing some examples for all of these, so I encourage you to check those out if you'd like more examples. And there are a ton of videos about coin and mixture problems if you go to YouTube and search for either coin or mixture problems. It'll do it. But I've got about 5 examples. Let's get started. Lesson 3.3, mixture, including money problems. And so for this is anything that has a value. So like coins or dollars, or even things like tickets, or even things that you buy in bulk. So like jelly beans or coffee, you can also do this type of stuff with. And so the key for this is this value times the number equals the total value. So let's do one that doesn't have any algebra in it, just to kind of see the process. And so if I have 4 nickels and 8 quarters in my pocket, how much money do I have? And so a lot of times you'll see this kind of chart that we will do too. So let's use N for nickels and Q for quarters. And so if I put up here my value and the number and the total. So what's a value of a nickel? Well, a nickel's worth 5 cents, which if we do that in the dollar form, it's going to be 0.05. What's the value of a quarter? Well, again, in dollar form, it's going to be 0.25. So our problem tells us that we have 4 nickels and 8 quarters. And so how do we figure out the value of this? Let's do that, 8. How do we figure out the value? Well, or the total value of each one. So we're going to take our 0.5, this is where our value times the number will give us our total value for the nickels. And then we can do something very similar for our quarters. And if I have 8 quarters, that'll give me $2. And so if I add those two together, then that'll give me the total value that I have in my pocket. So I have $2.20. So that's kind of the process that we're going to do. But of course, let's start talking with some unknowns. So let's look at the next problem. Connor has a collection of dimes and quarters with a total value of $6.30. The number of dimes is 14 more than the number of quarters. How many of each coin does he have? Okay, we've read the problem completely. Let's talk about what we need to find. We need to find each coin, right? So let's be a little bit more specific. What are the coins we're talking about? We're talking about dimes, which I'm going to call as D, and quarters that I'm going to talk about as Q. Let's go ahead and make our chart. And so dimes, quarters, and we're going to put value, number, and total. So what's the value of a dime? Dime is 10 cents, as the dollar form makes it 0.10. Quarter is 25 cents, in the dollar form is 0.25. And so now we need to do the number column. The number column gets a little bit more complicated here, and because we're not told how many of each we have. But we do have this sentence here. The number of dimes is 14 more than the number of quarters. And so if we use our math keywords in order to translate that, it says that D equals 14 more than, so remember this word than puts the 14 and puts it behind the quarters. Quarters plus 14. Now, was it super important to do that switch? No, but it's a good habit whenever you see that than to go ahead and put that number at the end. So if our D is Q plus 14. Then our quarters is just going to be quarters. Remember, we're going to want only one letter type in here. So if that one's going to be quarters plus 14, then this one also needs to be in quarters. So then to do our total, remember, we're going to multiply these together. So this one, because it's more than one term, we're going to go ahead and put it in parentheses to remind ourselves that the 10 gets multiplied by more than just the Q. Here we only have one, so we don't need to actually put that in a parenthesis. And then we're going to add those together, right? And it needs to equal, up here, it has a total value of 630. So let's go ahead and do that. So we've got 0.10 times our parenthesis Q plus 14 plus 0.25Q equals 630. Let's distribute in our 0.10. And the rest stays the same. We're going to combine like terms. In this case, we're going to subtract 1.4. Remember, when we're subtracting, we're lining up that decimal point. And so now we've got 0.35Q equals 4.9. Divide by 0.35. And we go to our calculator, divided by 0.35. And it tells us that Q is 14. So the number of quarters we have is 14 quarters. How do we figure out, but we want to find each of the coins, so we also have to figure out our dimes. Remember, our dimes is quarters plus 14. And so for us, that makes it 14 plus 14, which makes it 28. So 14 quarters and 28 dimes. That seems like a lot of coins. Let's double check that. So we would do 14 times 0.25, right? Plus 28 times 0.1. Let's go to our handy dandy calculator and see what that gives us. Sure enough, that does give us 6. Well, my calculator says 6.3, but since we're talking about money, let's go ahead and make that $6.30. So that was a good check. Check. Let's look at the next problem. Okay. This time we've got dollar bills. And so, but the process is going to be the same. John has $175 in $5 and $10 bills in his drawer. The number of $5 bills is 3 times the number of $10 bills. How many of each are in the drawer? So again, we've read the problem completely. What are we trying to find? Each bill. What specifically are we talking about with each bill? We've got $5 bills. Let's call it just X. And we've got $10 bills. Let's just call it Y for the moment. Okay, we've got values. Let's go ahead and do our little chart. And so we've got $5 bills and $10 bills. We're going to do value, number, and total. So what's the value that will go in the value column for $5 bills? Well, it's worth $5. What's the value that's going to go in the value column for the $10 bill? Well, it's worth $10. It's worth 10. Okay, so now we've got this whole number thing. We're not really sure of the number, they don't tell us, but they give us some more information. The number of $5 bills is 3 times the number of $10 bills. So if we use our keywords, so number of $5 bills, which we say is X, is, so an equal sign, 3 times the number of $10 bills. We're calling $10 bills Y, so this would be 3Y. Okay, so X, we said is here, right? This is our X and that's our Y. So our X is 3Y. And then remember, we only want one letter, so let's go ahead and leave that one as Y. We need to leave one as itself, and we're going to define the other in terms of the other. So, okay. So to find our total, remember we multiply these things together. And when we add them, we should get equals to the 175. Okay, so let's do that. So 5 times 3y plus 10y equals 175. So 5 times the 3y is 15y plus the 10y. Combine like terms, 25y. Next step is to divide by the 25. Handy dandy calculator tells us that's 7. And so y is, so there are 7 $10 bills. But we have to find both of them, so let's do the other one. X we said was 3y. So in this case, it's going to be 3 times 7, and that gives us 21 $5 bills. And we can check that if we wanted to.